All right, let's take a look at section 4.4, which is functions of any angle. All right. There we go. I need you to pause the video. I need you to fill in the definitions or fill in the vocabulary words and explain why you think it's important. Okay. So let's talk about theta, which is any angle, in standard position. Remember, standard position means the initial side is on the x-axis, positive x-axis, and the terminal side is right here. And this point right here, it's any point xy, any point on that line. So because we have the Pythagorean theorem, we know that this side squared plus this side squared equals the radius squared. So x squared plus y squared equals the radius squared, but if we just want the radius, we would square root. So that's where this comes from right here. R is equal to the square root of x squared plus y squared. And that is the distance between the origin and that point P. So if we want to define the trig functions, like the sine of theta, remember sine is the opposite over the hypotenuse. The hypotenuse is r. We are not necessarily putting this on a unit circle, right? So the radius is not guaranteed to be 1. Could be 1, but we're trying to do it where it's not on a unit circle. So y over r, keep in mind, yes, r is the hypotenuse, so y over r is the sine. The cosine would be the adjacent side, x over r. The tangent is opposite over adjacent, so y over x. Keep in mind that x cannot equal 0 because we can't divide by 0, cannot divide by 0. The cosecant is the reciprocal of the sine, so we take these two and reverse them. So r over y, and again, we have to make sure that our y value is not 0. And the secant and the cotangent. Again, making sure that whatever variable is on the denominator is not equal to 0. Okay, so let's suppose we have a point 1, negative 3. And we need to find the 6 trig functions. So the first thing we're going to do is plot that point, right? We're going to plot that point. So I'm going to make my hash marks. There we go. Nice and big. So here I have this point 1, negative 3, right? So I'm going to draw a line from the origin, and I'm going to draw a line straight to the quickest way to get to the x-axis, which is to go this way. And this gives me a right triangle right there. So this side of my right triangle is my x value. Well, I'm going 1 unit, so this is 1. This side of my right triangle, remember we went down 1, 2, 3. So technically it's a length of 3 units, but I'm going to put a negative 3 because that's my y value. And that will come into play with that negative there. So I do want to put a -3 instead of a +3. And I will also need r, okay, which is my hypotenuse. So 1 squared plus, I'm going to use a -3. 1 plus 9 is equal to r squared, so r is equal to the square root of 10. Okay, so this is 1, this is -3, and this is equal to the square root of 10, like that. Okay, so now I need to find my 6 trig functions. So my sine of theta. By the way, the theta is always going to be with the x-axis, not with the y-axis. So this point right here is, well, technically this is theta, but this is the one that I'm looking at for opposite over adjacent, that kind of thing. So the sine is going to be the opposite, which is -3, over the hypotenuse, which is the square root of 10. Another way you can think of that is y over r. Y over r, it's the same thing. So we would need to rationalize the denominator, and we would get -3 square root of 10 over 10. Notice I used a -3, not a +3, because my sign is going to be negative in that quadrant, because my y value is negative in that quadrant. The fourth quadrant over down here, Q4. My y value is negative, right? Because we're going down. Okay. Cosine theta is the adjacent side, 1, over, and that is a positive 1, because we're going in the positive x direction, over the hypotenuse, which is the square root of 10. Another way you can think of it is x over r, and we have to rationalize the denominator. So we end up with the square root of 10 over 10. It's going to be the cosine. And we still need the other 4 functions, but so we need the tangent of theta, that's opposite over adjacent. So this was 1, this was -3, and this was the square root of 10. So opposite, which is -3, over the adjacent, which is 1. You can think of this as y over x. We end up with -3. The cosecant, that is the reciprocal of the sine, right? The c goes with the s. Well, the sine is opposite over hypotenuse, so we need the hypotenuse over the opposite. All right, so that gives me the square root of 10 over -3. We need the secant. The secant is the reciprocal of the cosine. The cosine is adjacent over hypotenuse, so we need the hypotenuse over the adjacent. R over x. So square root of 10 over 1. And then we need the cotangent, which is reciprocal of the tangent. So 1 over the tangent. So instead of opposite over adjacent, we're adjacent over opposite. So that would give me x over y, which is going to be, what's my x? 1 over negative 3. All right. Evaluate the cosine function and the cosecant for this quadrantal angle, which is 0 degrees. This is 0 radians. All right, so we know the cosine of 0 degrees is going to be x over r. Well, this is my x, right? This is my y. So we're at the point 1, 0. And I know it doesn't make logical sense because we don't actually have a triangle, but this is a distance of 1 unit. So we say the radius is equal to 1. So we would do 1 over 1, simplified is 1. The cosecant of 0 degrees is 1 over the sine of 0 degrees. And remember, the sine is the y value. The sine is the y value. So this is saying 1 over 0, but you cannot divide by 0. And so this is undefined. The cosecant is undefined at 0. Find the cosine and the cosecant for 90 degrees, which is the same as pi over 2. You really need to know that. So the cosine of pi over 2. So now we're here, right? Here's my angle. So now we have an x of 0 and a y of 1. So the cosine, and again, the r is equal to 1. So the cosine is x over r. So my x is 0, my r is 1, and I get 0. Okay, so that's perfectly fine. Nothing wrong with that. The cosecant of pi over 2 is 1 over the sine and 1 over the sine. So the sine is the y. There we go. We end up with 1. Cosine and cosecant of pi. Okay. All right, so rinse and repeat. So cosine of pi, we are going to take the x over r. My x is negative 1 over 1 equals negative 1. The cosecant of pi is 1 over the sine of pi. 1 divided by the sine is the y value, and this is undefined. What else we got? 3 pi over 2. Okay, so now we're going 3 pi over 2. That's this one right here. And again, we're at the point P, which is 0, negative 1 this time. And yes, cosine. Cosine of 3 pi over 2. So we take the x over the r. X is 0. The radius is equal to 1, we get 0. And the cosecant of 3 pi is 1 over the sine, which is 1 over the y value. The y value is -1, and we end up with -1. I hope that's it, because that's getting kind of boring. Okay, what else we got? Okay, whether or not the trig functions are positive or negative, and which quadrants are they positive or negative? There's two different ways to remember this, and I feel like I'm in the minority. I think I'm one of the only people I know that remember it differently from everybody else. So you can remember it whichever way makes most sense to you. I remember it best by thinking of the x's and the y's. So in quadrant 1, both my x and my y are positive. They're both positive. So that means my sine is positive, my cosine is positive, and all derivations thereof, meaning the tangent, the cotangent, the cosecant, the secant, all of them are going to end up positive. Okay? With quadrant 2, because I'm going to the left, my x is going to be negative and my y is going to be positive. Okay, so I have a negative x and a positive y. Okay, so what does that mean? Anything that has to do with an x is going to be negative. So what has to do with an x? So the negative ones, okay, those are going to be the cosine, the secant, the tangent has an x in it, the cotangent has an x in it. These are all going to be negative. And so the ones that are positive are the ones that just have a y. They don't have any x's. So that would be the sine and the cosecant. Okay, so those are the positive ones. Quadrant 3, both my x and my y are negative. So you would think that would make all of the functions negative. That's not the case. So all of my x's, so my cosine and my secant, and my y's, that would be the sine and the cosecant. But the tangent and the cotangent are both positive. Let's talk about why. The cotangent and the tangent are both positive because for the tangent, we do y divided by x. In other words, we have a negative divided by negative, and that's positive. And same thing with the cotangent. We have the x over the y, they're both negative, and a negative divided by negative is positive. So there's only two functions that are positive in quadrant 3. And finally, quadrant 4. My x is going to be positive, my y is going to be negative. So what am I going to have for my negatives? Anything that has to do with y, which is the sine, the cosecant, the tangent, and the cotangent. And then the positives are going to be the cosine and the secant. Okay. How does everybody else remember it? Well, they have a mnemonic. You know what that means, right? You just have letters that represent words. So all students take calculus. All stands for all the functions are positive. All positive. students, that's the sine is positive, and the one that's the reciprocal, which is the cosecant. Cosecant's going to be positive. Take, so that would be the tangent is positive, and then the reciprocal, which is cotangent, is positive. And then calculus, C is a cosine. So here's my S, my T, and my C. And then the cosine is the secant, the reciprocal is the secant, so that would also be positive. Whichever way you want to remember it, you just need to remember it. So whether you want to think of it as x's and y's, or you want to think of it as all students take calculus, your choice, it really doesn't matter. For me, it just makes, for me personally, it just makes more sense doing x's and y's. But whatever is easier for you. Okay, so we have, so here's what I'm going to do. I'm going to draw my quadrants, right? And so I'm going to put a plus and a plus, and my x is going to be negative and a plus, and negative. You will actually see this sometimes. I'm not the only person that does it this way, but and then my x is positive, and my y is negative in quadrant form. Okay, so all students, that would be the sine and the cosecant, take, that's the tangent and the cotangent, calculus, the cosine and the secant. Okay, so the sine has to be negative, less than 0. Okay, so where is, okay, so the ones that I wrote, those are where they're positive, right? So the sine is positive in quadrant 2 and quadrant 1. So it is going to be negative in quadrant 3 and quadrant 4, which makes sense because the y value is negative in quadrant 3 and quadrant 4. But the cosine also has to be negative. Well, the cosine is positive in quadrant 4, so it has to be in quadrant 3. All right, has to be in quadrant 3. Okay, so they give us the tangent, which is negative 1/3. So the tangent is negative, and the cosine is also negative. Okay, so we have to figure out which quadrant. So everybody's positive here, so it can't be that one. The x is negative, the y is positive, so the tangent would be negative in this quadrant. We already know that negative, negative, when we divide those, it's going to be positive, so it can't be this one. And then x is positive, y is negative, so it could be that one. When we divide those, it would be negative, so it's possible it's in quadrant 2 or quadrant 4, and the cosine has to be negative. Well, the cosine is the x. My x is positive in quadrant 4, so it's not that one either, so I'm in quadrant 2. Okay, so I'm in quadrant 2. And I have right here, and I'm going to draw a triangle. And this is going to be my theta. Right, you always go down to the x-axis. Go down to the x-axis or up to the x-axis. You never go to the y-axis. All right, so here's my angle, and it's negative 1/3. Okay, so my x is negative, right? So I'm going to put my negative 1 here, and my y is positive. So I'm going to put a positive. whoops, I did that wrong. Hold on. Okay, I'll try again. Remember the tangent, which is what I was blanking on, spacing on, is opposite over adjacent. Okay, so my opposite is going to be the number on top, and the adjacent is going to be the number on the bottom. So opposite is going to be 1, and adjacent is going to be 3. But because this measures my x, and my x is going in the negative direction, I'm going to put a negative 3 there. Okay? All right, so my x is equal to negative 3, and my y is equal to 1. So I need to find r. Negative 3 squared plus 1 squared gives me the square root of 10. So that's my radius. And what do they want us to find? The sine. So first, we're going to do opposite over hypotenuse. So opposite is my y, which is a positive 1, over the hypotenuse, which is my radius. Radius is always going to be positive. Rationalize the denominator, and we end up with the square root of 10 over 10. Now, just double check, is the sign positive in quadrant 2? Well, yes it is. All students, that would be your sine, and our cosecant, yes, it is positive in quadrant 2. Okay, so we're good on that. And the secant. The secant is the reciprocal of the cosine. We already said the cosine was negative, so we're going to should end up with a negative number. And we're going to, what's my cosine? The cosine is adjacent. So the cosine, they didn't ask for it, but I'm just going to do it. Adjacent over the hypotenuse. So I need the reciprocal. So this is going to give me, and we've got a negative there. So negative square root of 10 over 3. And is the secant negative in quadrant 2? Yes, because the only ones that are positive are the sine and the cosecant. So we got it, our positives and negatives correct. Let's talk about a reference angle. Remember how I said you always go towards the x-axis? You just always go towards the x-axis. So let's suppose you have an angle like this, right? So it's an obtuse angle, right? You can't just make a triangle, a right triangle, with what we have right now. So what we do is we make a right triangle with the x-axis. So we go down to the x-axis, and then we look at this angle right here. This is called the complement, and we usually refer to it as the reference angle. It turns out that reference angles will have the same sine, cosine, tangent, etc. as the angle that we're looking for, with a possible exception of whether it's positive or negative. Okay, so you just have to take into account the quadrant. Reference angles are our friends. We love reference angles when we're in radians. This is why we love radians. I'm going to tell you, we love radians because of reference angles. When it has to do with degrees, reference angles are a pain in the backside. So, what do I mean by that? you have to get to the x-axis, okay? So if you are here, right, to get to the x-axis, we need to take 180 degrees and subtract off our angle, and that will give me our reference angle right there. Okay, sounds easy, right? Huh, okay. Well, and this, guys, this is only for degrees. I'll show you what you need to do with radians in a minute because it's so much easier. So we need to get to the x-axis, okay? So we know that this angle right here is between 180 degrees and 270 degrees, but we just need this portion of it, which is my entire angle, subtract off 180 degrees, and that will give me this little itty bitty angle right there. I told you we don't like degrees. And then right here, all the way around is 360, but I just need this little portion of it right here. So we take our angle and subtract, or sorry, we take 360 and subtract off our angle, and that will give us our reference angle. Oh, so much easier when we have radians. You'll see. So 210, we need to figure out which quadrant it's in. So it's past 180, but it's not quite to 270. So it's right here. Right, so here's my 210. I need this portion of it. So I'm going to take my 210 and subtract off 180. And that will give me my remaining reference angle. So 210 minus 180 gives me, what, 30 degrees. That's my reference angle. All right, you ready for the radians? See this number right there? Don't put an equal sign. There you go, reference angle, done. You're like, but wait, can that possibly be true? Yep. Does it work every time with radians? Yes, it does. So, well, as long as it has a pi in it. I misspoke. Okay. So we have 7 pi over 4. Okay, so this is 1, 2, 3, 4, 5, 6. Here's my 7 pi over 4, and I need to get here. So I'm going to take 2 pi and subtract off 7 pi over 4. 2 pi, subtract off 7 pi over 4, multiply by 4. That gives me 8 pi over 4 minus 7 pi over 4. And look, pi over 4. Works every time. Um, 240, negative 240, sorry. Have to figure out what quadrant it's in. It's easier to figure out what quadrant it's in if it's a positive, to be perfectly honest. So I'm going to add 360 to this. To get it as a positive angle. And if we take 360 and add a negative 240, that gives me 120. Okay, so my angle is right in here. Here is my negative 240. Okay? But it's equivalent to 120. So I need to get here. Okay? so this time I take 180 degrees and subtract off my 120. And so my reference angle is 60 degrees. So this is in radians. Yeah, when it doesn't have pi in it, it makes it a little bit trickier, but you know that halfway around is pi radians, right? Well, pi radians is 3.14 approximately. Okay, so this is 3.6. So it's a little bit beyond halfway. So there's my angle. So I need to take my angle and subtract off pi. So 3.6 subtract off pi. And that will give me approximately 0.46 is the reference angle. It's rare that you have to do that. Most of the time, if it's in radians, you're going to have a pi attached to it. If it's greater than 360 degrees or greater than 2 pi, just keep subtracting off 360 or 2 pi until you get between 0 and 2 pi, and then find the reference angle from there. Okay, so you really want your angles to be between 0 and 360. Actually, it's probably not equal there. And remember, 360 is the same as 2 pi. So let's see if we have some examples here. Okay. I'm not sure what this is doing over here, to be honest. Okay. So we take the 665. Notice it's bigger than 360. So we subtract off 360. And we get 305 degrees. So here's my 305 degrees. And I need to get this one, so that's my 360 minus 305, which gives me a 55-degree reference angle. Oh, look, it has pi over 4. Oh, look, it has a 3, pi over 3. I told you you're going to like radians. Okay, I already mentioned this, but trig function values are going to be the same as our reference angles with the possibility of having a different sign, positive or negative. Just depends on whether, reference angles are always going to be in the first quadrant. All our reference angles are going to be over here. So they're always going to be positive. But our actual angle could be over here, right? Where everything's negative except tangent and cotangent. So the reference angle will give us the number we need. The quadrant will tell us whether it has to be positive or negative. Find the reference angle, find the function for that reference angle, figure out which quadrant it has to be in, and then use the appropriate positive or negative. I don't like doing it with degrees. We don't like degrees. Okay, so we have to find the reference angle. Okay, so 270 gets me this far around, so it's a little bit more than that. So here I am with my 300 degrees. Okay, so this is my reference angle right here. So what I'm going to do is I'm going to take 360 minus 300 gives me a reference angle of 60 degrees. So this is 60 degrees. What we're going to do is we're going to find the sine of 60 degrees. Okay. Remember, 60 degrees is the same as pi over 3, if that helps. Sine of 60 degrees is the same as sine of pi over 3. And you have to remember these guys. Remember with the sine, right? It goes 1 over 2, square root of 2 over 2, square root of 3 over 2. And this is going to be my pi over 6, pi over 4, and pi over 3. So this is one we need right there. So the sine of 60 degrees is the square root of 3 over 2. Okay? But we have to figure out if the sign is positive or negative in quadrant 4. The sign, so the x is positive, the y is negative, and the sign is the y. So my sign is a negative. So sine of 300 degrees is going to be a negative square root of 3 over 2. Oh, yes, we like radians. All right, so we need to figure out which quadrant it's in. Okay. So you know I'm dividing this into 8 equal pieces, right? And then these 4 pieces are pi, and these 4 pieces are my second pi or 2 pi. So that's why I keep making that little x, so I can count the pi over 4s. So here is my first pi over 4, my second pi over 4, 3, 4, 5. I have 5 pi over 4 right here. Okay, reference angle, pi over 4. See how easy that was? The tangent of pi over 4 is 1. You get that from your table. Got to remember your table. Now we have to figure out whether the sign is positive or negative in the third quadrant. Well, my x is negative, my y is also negative, and we divide those, negative divided by negative, my tangent is going to be positive. So the tangent of 5 pi over 4 is going to be a positive 1. All right, what else we got? Secant of negative pi over 6. Well, negative pi over 6 is going this direction. Here's my negative pi over 6. So it is in quadrant 4. And that is, the x is positive, the y is negative, and the secant is 1 over the cosine, which means it's going to be positive. Okay? So, because the cosine is my x value, so it's positive in the fourth quadrant. So my answer is going to be positive. Okay, so basically we just have to find the secant of, remember reference angles? This is a 6, pi over 6. Okay, you're like, but wait, we don't know the secant of pi over 6. Well, we do know that the secant is the same as 1 over the cosine. So 1 over the cosine of pi over 6. Okay, So with my cosine, that's 3, 2, 1. So square root of 3, square root of 2, and 1. Okay, pi over 6 is the first one. So that's the square root of 3 over 2. So this is the reciprocal of that. So 2 over the square root of 3. Rationalize the denominator. And we get 2 square root of 3 over 3. And once again, we already just said that it has to be positive. So secant of negative pi over 6 is a positive 2 square root of 3 over 3. Learning reflection. There you go. Don't forget to answer these questions.